So let's take a look at a few properties of the natural logarithm, ln, to begin with. First of all, the domain and the range. The domain is going to be from 0 to infinity, with 0 not included. And the range is negative infinity to infinity. Now this is very obvious when we draw a graph of it, because ln x looks just like this. That is 1. And as x approaches 0, if I take the limit as x approaches 0, this thing is shooting down to negative infinity. And this is monotonic increasing, so this is actually heading up to infinity. It's undefined for negative values and 0. Now, log of x plus y, this is really just an algebra review. You've already done this probably 1,000 times in algebra and pre-calculus class. Log of x plus y is equal to the log of x plus the log of y. So ln xy is equal to ln x plus ln y. Now remember, back when you first was introduced the idea of natural log, or logs in general, logs are exponents. That's what a log actually is. It's an exponent. So what happens when we multiply two things together the same base? We add their exponents. So I'm multiplying here, so I'm going to add the exponents. Now ln of x over y, what happens when I divide two exponential functions, or two functions with the same base? I subtract their exponents. So this is going to be ln of x minus ln of y. Let's see, ln x to the p, for p a real number, with the exponent, that's p is just the exponent. This is the same as, and this is really one of the most powerful features of the logarithms, how we very commonly use them to solve solve equations, is this is the same as p times log x. When I take the log, the exponent can come out front. Now, ddx of ln absolute value of x is going to be equal to 1 over the absolute value of x, obviously for x non-zero. See, by using the absolute value, I can now take on negative values of x, because I'm dealing with the absolute value. The derivative, ddx of ln of the absolute value of u of x, is going to be equal to 1 over the absolute value of u of x times u prime of x. And this last one here, if I integrate 1 over x dx, this is actually equal to the natural log absolute value of x plus c. I still have that constant of integration, because this is an indefinite integral. And very commonly we simply write this as ln of x. You may take a look at the function to make sure that we're only dealing with positive values, but it's very common to drop that absolute value.